Today is Wednesday, September 8th, 2021. Welcome to the 18th Annual Spinal Cord Injury Awareness Day at the State House in Boston, virtually from my computer room. My name is Dr. Eric Ruby, founder of Massachusetts Walks Again. This meeting is coming to you on a Zoom webinar with the help and support of the Greater Boston chapter of United Spinal Association. Across the nation, September is Spinal Cord Injury Awareness Month. Let me begin with a proclamation signed by Massachusetts Governor Baker. Whereas the estimated number of people living with spinal cord injuries in the United States is approximately 294,000 persons, with a range of 250,000 to 368,000. And whereas every year, approximately 400 to 950 people sustain a non-fatal spinal cord injury in the Commonwealth of Massachusetts, and whereas spinal cord injuries can result because of motor vehicle accidents, violence, falls, sport, and occupational accidents, and whereas these injuries range from paraplegia to quadriplegia, whereas through public awareness, the Commonwealth of Massachusetts seeks to minimize the devastating effect of SCI. Now, therefore, I, Charles D. Baker, do hereby proclaim the month of September Spinal Cord Injury Awareness Month. Signed, Charles D. Baker, Governor, Karen Polito, Lieutenant Governor, and William Francis Galvin, Secretary of the Commonwealth. Each year since 2004, quote, those whose work and life exemplified service, commitment, and compassion for those with spinal cord injuries receive this award. 3 distinguished recipients who well deserve our appreciation and recognition will share the award this year. Our first recipient in 2021 is Ryan DeRoche of the Greater Boston chapter of United Spinal Association. He deserves the credit for putting this program together virtually and has suffered my additions, deletions, and corrections for over 3 months. He has worked tirelessly on the agenda you see before you. Our second recipient is the director of the National Institute of Allergy and Infectious Diseases. The pandemic has adversely affected the SCI community, as it is estimated that 20% of those with SCI would succumb if infected. Dr. Anthony Fauci's guidance has protected and advised us with encouragement of best practices based on known science. This award is recognition of his wisdom, knowledge, and leadership in times of a public health crisis with unimaginable consequences.
Warm greetings to you all. My name is Tony Fauci, Director of the National Institute of Allergy and Infectious Diseases at the NIH and Chief Medical Advisor to President Biden. I am humbled and deeply grateful to Massachusetts Walks Again for honoring me with a proclamation signed by your governor in recognition of Spinal Cord Injury Awareness Month, September 2021. I would like to thank all of you, Dr. Eric Ruby and his colleagues, patients and their families, as well as researchers who are working so hard to develop treatments and cures for spinal cord injuries. Your outstanding efforts in advocacy and science are leading to important advances in awareness and research. Thank you for all you do, and let me say again how grateful I am to be honored. Please stay safe, keep well, and continue your important and outstanding work.
Our third recipient is a Massachusetts physician, the present director of the CDC. Dr. Rochelle Walensky's dedication to the safety and protection of the citizens of the United States, with particular attention to those at high risk during the pandemic, is appreciated and acknowledged. We are proud of the work she has done and recognize the crises she faces daily. This award is a symbol of the lives she has saved and impacted. We will now hear from Taunton Senator Mark Pacheco, who has been instrumental in guiding our legislative funding efforts, followed by data from Rebecca Thomas of the Massachusetts Department of Public Health, and then our 5 research grant recipients, interspersed with educational and informative infomercials from our network of supporters. Please note that Dr. Andrew Thomas was selected to display his Massachusetts funded research at the annual Neurocritical Care Society's meeting in Chicago in October. We also have a tribute to Travis Roy. Following today's presentation, there will be a live Q&A based on the questions received in the chat box. Those questions that we cannot answer because of time will be referred to the appropriate person for whom the question is intended. Thank you.
Hi, this is State Senator Mark Pacheco, and I'm here today to celebrate with you Spinal Cord Injury Awareness Day here in the Commonwealth of Massachusetts. It is a day for us to take stock in where we are in terms of the advocacy efforts to bring attention to spinal cord injury, to look back over the last 18 years or so that so many of us have been involved in this issue, and to, in particular, look at the funding levels that we have achieved together. This is a marathon that we're on and not a sprint. We've been working on this for about 18 years. We've seen improved funding, in particular, as a result of the 5 research grants that we have seen that have taken place thanks to the passage of the Thomas Kennedy bill that we did a few years ago with my colleagues in the legislature. We want to thank the Travis Roy Foundation and all of those leaders that worked with us to try to do what we could do, because we understood that the funding is needed, and research saves lives. And the money in the long run is an investment for our collective future so that Massachusetts can walk again. This is a true humanitarian effort, and I want to thank my friend and pediatrician here in the city of Taunton, where I'm recording this from, Dr. Reeve, for his leadership, for his inspiration, for him bringing me to this movement. I can't say enough about him and so many of you that are out there, the researchers, the families that care as Dr. Reeve and his family has with the challenge that his son has faced and all families face as a result of spinal cord injury. So let us keep working together to improve where we are. We went from a low of 23,000 approximately to now in FY 2021, $1,230,415. Congratulations to all of you. That $1.2 million plus is because of your effort, changing laws and making sure research dollars are available. Congratulations and thank you very much.
Hi, everyone. My name is Becca Thomas. I'm the Director of Injury Prevention and Control at the Massachusetts Department of Public Health, where I have the pleasure of overseeing the Thomas P. Kennedy Spinal Cord Injury Trust Fund. I wanted to share some data with you today in honor of Spinal Cord Injury Awareness Day, and also give you a little status update on the trust fund and our contractors who are awarded funds through the trust fund. So as you can see on the data slide in front of you, we have data through 2018 related to spinal cord injuries. In 2018, there were a total of 940 non-fatal spinal cord injuries in Massachusetts. That included 129 emergency department visits and 811 hospital stays. This is an inverted injury pyramid. Usually when we look at the injury pyramid, you see that emergency department visits are at the bottom and deaths are at the top. The fact that we see more hospitalizations related to spinal cord injuries than we do emergency department visits speaks to how severe of an injury a spinal cord injury is. We also see in the data that we have some disparities when it comes to sex related to spinal cord injury, with males sustaining spinal cord injuries at a higher rate than females, and that gap has persisted over time. The leading causes of spinal cord injury are falls and motor vehicle traffic crashes. We've also broke down the data for the past few years by age and by race and ethnicity. So as you can see, the group that has the most frequently occurring spinal cord injuries are those 65 plus. But as time goes on, we see with age that the risk increases. We also see fairly large disparities between white non-Hispanic, Black non-Hispanic, and Hispanic race and ethnicity in terms of suffering a spinal cord injury. While we don't have all of the data about why we see these disparities, why Hispanic folks are more prone to spinal cord injury than other races and ethnicities, we think that there may be something underlying relating to motor vehicle crashes. The Hispanic population is also overrepresented in terms of car crashes. So that may be causing this large disparity that we see. And as I'm sure many of you are aware, the Thomas P. Kennedy Spinal Cord Injury Trust Fund has been in place for a number of years now with the goal of finding a cure for spinal cord injury and to promote treatments to overcome the effects of chronic spinal cord injury. It is maintained of revenue from a $50 surcharge to the person seeking to get their driver's license reinstated after suspension for multiple moving violations. In fiscal year 22, which ended on June 30th, we had a balance of nearly $2 million in that account. And in fiscal year 20, we had nearly $1 million deposited into the account, which means that we're able to fund a number of research initiatives. Currently, we're funding 5 organizations for research on spinal cord injury, including Boston Children's Hospital, Boston University, Harvard University, Mass General Hospital, and Spaulding Rehabilitation Hospital. I'm very glad to say that those contracts have been renewed for fiscal year 2022 and fiscal year 2023. So we are fully funded for these projects through June 30th of 2023. We also maintain a website on spinal cord injury. So if you visit mass.gov/spinal cord injury, you can find out more about our contractors who are conducting this very important research, as well as some additional data. We'd be happy to answer any additional questions you have. So please do feel free to reach out to me at rebecca.thomas@mass.gov. Thank you.
Our chapter is honored to help Massachusetts Walks Again with the production of the SCI Awareness Day event. For nearly 30 years, our chapter has supported thousands of individuals with spinal cord injuries and disorders and their families through peer mentoring, support groups, education programs, grants, and social events. Our peer mentor program matches individuals as well as their family members one-on-one with a peer mentor.
I oversee our 11 virtual support groups, which are designed to meet the various needs of our members and their families. In addition to our weekly general support group, we also offer groups for those with new injuries, women, Spanish speakers, significant others, family members, and children who have a loved one with paralysis. We also offer a nutrition group and an After Dark series to discuss intimacy and relationships for significant others, men, and women. Our monthly Saturday education series features presentations on topics relevant to spinal cord injuries and disorders.
The support groups provide a safe, non-judgmental space to talk about the opportunities and challenges involved in providing care to our loved ones. We openly share experiences, ideas, opinions, and concrete suggestions and resources that have been very helpful. It makes a significant difference to have people who truly understand, care, and are there for you.
I have found the SCI support groups to be very helpful in talking about our experiences and making concrete suggestions for conquering our physical challenges. It's also a terrific place to learn about and suggest resources and equipment such as manual and power wheelchairs. We learn a lot from each other.
My name is Maria and I do support group. Gracias a todos por escucharme. I like to do support group because I enjoy doing that, and they give me the support to help others, and provide the support others, making me feel so happy, and I enjoy do every day.
We also offer 2 grants. One is for durable medical equipment or an assistive technology device, and the other is for vehicle modifications.
I recently received a grant from the GBC chapter of the United Spinal Association to have adaptive hand controls installed in my vehicle. The grant award has been very useful and has made a positive impact on my daily life. I am now able to attend to my medical appointments, work, and other activities of daily life independently. Thank you, GBC.
Visit us at sciboston.org to learn more about our chapter and our ongoing programs. Please let us know how we can support you.
Chris Gable, I'm a professor of physiology and biophysics at Boston University School of Medicine. And my lab is interested in studying nerve damage and regeneration on a single cell level. So a spinal cord injury or traumatic nerve damage, you need to have the neurons grow back to regenerate. Those cells need to grow back and reconnect. And so what we're looking at here is a very controlled experiment. We have a single neuron, which we've cut with a laser in an intact animal, and now we can watch it regrow, watch it regenerate over time. And so we're looking at nerve regeneration on a single cell level. What that allows us to do actually is to look at the processes behind that. So the cellular mechanisms that are allowing this outgrowth. And particularly we've looked at the genetics controlling it. So we found a number of mutants. So these are alterations in specific genes that are allowing these cells to grow farther, to increase the amount of regrowth and recovery you have after damage. So we have these 2 genes, OGT and OGA. You can see here, this is time after laser cutting the neuron, and amount of growth outgrowth you have, and the wild type here is in gray. So that's the normal outgrowth. We get almost twice as much with these mutants. And then that leads us to pharmacological treatments that are targeting those genes, those proteins. And so the drugs then are targeting the same process that the genetics was and give us the same effects. We get increased outgrowth with that pharmacological treatment, which is going to lead to therapy down the road. So what is going on? What are these genes actually affecting? So they are actually modulating cellular metabolism, so how a cell uses energy. And so you imagine you damage a neuron, needs to grow back. That's highly energetic. It needs a lot of energy to do that. So the cell metabolism is a key part of that. And we've actually found this one metabolic pathway, 1-carbon metabolism, is involved in that process. And so if we knock out specific genes involved in that, SAMS1, we can eliminate our enhanced regeneration. So here again on the right, we've got normal outgrowth after cutting. It increases with the OGT mutation. And then we have 2 mutations, OGT and a SAMS1, we get rid of the outgrowth. And so that's really telling us that this is the pathway that's helping us increase regeneration. So 1-carbon metabolism controls a lot of things, but a major role is to control methylation of DNA and histones, which is going to change gene expression. So it's going to alter the amount of genes that are expressed and the level of their expression. So most recently, what we've done is we've looked at in a neuron-specific way, looked at the differential gene expression. So which genes are overexpressed, which genes are underexpressed, comparing the wild type to these regenerative mutants. And that's giving us a short list of genes that are involved in this process. So these are genes that are involved in DNA and histone methylation that are going to be part of that same pathway that allows us to increase outgrowth, to increase regeneration, and really target the control, that genetic control of regrowth after damage. So we're really getting at the cellular processes that are necessary for this increased regeneration. And that is going to lead us then to therapeutic targets and new methods of therapy after nerve damage and spinal cord injury. So with that, I would like to thank Dr. Dilibyadev, who's an excellent postdoctoral researcher on the project. Of course, it's great to be part of the CSI Awareness Day. And then thanks to the Massachusetts Spinal Cord Injury Cure Fund for support of the project. Thanks.
Located in Canton, Massachusetts, Journey Forward is a nonprofit organization dedicated to bettering the lives of those with paralysis through an intense exercise-based program. As part of the Neurological Recovery Network, Journey Forward offers our clients the most up-to-date techniques, modalities, and equipment to give them the best opportunity to overcome their situation. The secondary complications that come along with individuals confined to a wheelchair can become painful, costly, depressing, and in some circumstances, even fatal. It's so important for those individuals confined to a wheelchair to be standing, moving, and exercising to not only try to get stronger to make their day-to-day lives a lot easier, but even more importantly, to be able to live a long, healthy, quality life.
Hi, my name is Matt Brown. I'm a C4 quadriplegic, and I've been coming to Journey Forward since 2010.
What makes this place so special is that as good as it is for the body, it's even better for the mind to come to a normal gym. You got people working out, people cheering each other on. If you're having a good day, having a bad day, no matter what, you leave this place feeling better, both physically and mentally.
Hi, my name is Sherry. I had a spinal cord stroke just about a year ago, and I've been coming to Journey Forward since September, and I can't believe what a difference they have made here. It's a great place to be, and I look forward to it every single week.
Hi, my name is Brandon Conde, and I've been roughly going to Journey Forward for 18 months. Journey Forward has helped my road to recovery more than I could possibly ever imagine. The specialists I've worked with created a program suitable for my specific spinal cord injury. It helps with my day-to-day tasks and activities, as well as an increase in strength. Plus, having a community of people who understand my struggles is always a plus. Dude.
First of all, I would like to thank all of you for participating in this annual gathering and supporting our research on spinal cord injury. My name is Shigang He from Boston Children's Hospital. A major focus of my lab is to study axon regeneration after spinal cord injury in hope to find a cure for the patient. This is the MRI image from patient with a spinal cord injury showing a lesion that damages a spinal cord. In my lab, we applied different injury paradigms to mice to model spinal cord injury. In both patients and models, a common feature is the damage of brain-derived nerve fibers or axons, which is a key mechanism of paralysis. With these models, we ask the questions, first, how to promote axon regeneration. Second, how to enhance the function of regenerated axons. In the past, we discovered a number of methods that can promote the regeneration of corticospinal axons, those nerve fibers from the cortex all the way projecting to spinal cord. In control, injured corticospinal axons cannot regenerate. However, if we delete a molecule, a gene called P10 in the cortical neurons, then these animals will be able to regenerate cortical spinal axons. We also discovered that other methods of activating mTOR pathway can also promote cortical spinal axon regeneration. However, it is well known that several brain regions send their command projections from the brain to the spinal cord, likely controlling different aspects of the spinal function. Cortical spinal neurons only part of it. Other known projections are from rubrospinal neurons in the midbrain and reticulospinal neurons in brainstem. In order to achieve meaningful functional recovery, it is important to find a way to promote the regeneration of these axons as well. This is the objective of our project, currently supported by Mass WorkScan. In the past years, we have established the method of consistently and efficiently targeting these neurons. Now we are testing if mTOR activation method could promote this axon regeneration. In the meanwhile, we are also analyzing the molecular signature of this different population of neurons in order to find a novel target for promoting axon regeneration. We are grateful for the support provided by Mass WorkScan and all people behind it, in particular, Dr. Eric Ruby. Our spinal cord injury research is also supported by other funding agents, including NIH, the Adelson Foundation, and the Wings for Life Foundation. Thank you.
Our main model organism is the lamprey, which is looks like an eel, but is a fish. And the lamprey is really cool because it's a very primitive vertebrate. It evolved about 550 million years ago from a common chordate ancestor. And even though they're so primitive and so old in evolutionary terms, it turns out they have brain and spinal cord structures that are very similar to the ones that we have in our own bodies. Unlike humans, if you sever the spinal cord of a lamprey without any treatment or intervention whatsoever, you can put the animals back in the tank, and over the time course of about 3 months, they're able to fully recover their ability to swim. So the real question is, if they can do it, why can't we? Because the similar injury in humans, the person is going to be confined to a wheelchair or have other sensory and motor problems likely for the rest of their lives. So this big group of collaborators came from 4 or 5 different institutions over several summers here at the MBL to start to look at that molecular recipe for successful regeneration. The remarkable thing that we found was that lampreys are turning on genes that promote growth in the peripheral nervous system of humans. That tells us that there's an evolutionarily conserved program that's able to drive nerve regeneration from this very primitive lamprey all the way to humans. And if that's the case, if we could figure out how to turn on that program in humans, in the spinal cord or in the brain, we might have better successes in the clinic.
Good afternoon, everyone. Thank you for spending these few minutes with me as I tell you a bit about what we're doing with our Commonwealth of Massachusetts Spinal Cord Injury Trust research grant. I just want to give my own dedication and tribute to my friend and colleague, Travis Roy, who we all know as a passionate leader, renowned speaker, but to me, a friend, teacher, and what few of us can say, an improver of the world. My simple drawings on this flip chart are aimed at telling you how we are approaching finding out the molecules within the front end of axons, and I'll explain this, that might lead to transforming them from unable to regenerate after spinal cord injury to an ability to grow as if they were building the nervous system during development. So the brain, shown here from the front, the eyes, the cerebral cortex, has these red neurons that connect through their long arm-like axons down to neurons in the spinal cord to control the arms or the legs or bowel, bladder, or sexual function, and other neurons living in these orange balls who send out parts of themselves to sense signals and bring them up into the brain. And as we all know, in spinal cord injury, it's not a problem of the neuron cell bodies themselves being damaged, but rather when the normally protective vertebral bones are crushed or injured, those axons down from the brain or up to the brain are crushed or severed or made to not function. So let me blow that up for you. And this cell body, the control center of a neuron, with its DNA in the nucleus and its dendrite input, has almost all of its volume in its arm, in its axon. And that can extend 1,000 to 100,000 times the size of this cell body. So this neuron here on my flip chart would actually send its axon a few football fields long. And if it were as large as my 6-foot-tall body, my arm would extend from Boston City Hall to Braintree or Marion or Providence, depending on what I was controlling, the face or the arms or the legs. And when neurons set up that circuitry during development or embryonic growth, these leading parts of the axon, the so-called growth cone, can grow through the young brain, through old brain, even through injured brain in many experiments. So those young growth cones can generate and regenerate. What allows such amazing growth? What are the RNAs and proteins and signals that we might like to use to make neurons regrow after injury? Well, in injury, those growth cones try to reform, but they ball up into a blocked so-called retraction bulb. They stop. But kudos to Zhigang He's lab, who we've already heard about, my close friend and colleague, who's been able to use certain treatments to get some of those axons to grow partially. But there are risks of those treatments. So if we could only look and study the growing or blocked or developing axons and find out what molecules are inside that allow generation and regeneration, that could lead to new treatments. And that's exactly what our grant is doing. So the big picture is we've come up with entirely new approaches to take out all the molecules from growing or blocked or trying to regrow growth cones in spinal cord injury. And this leads to a new ability to investigate the working end of the axon for spinal cord injury. And we're aiming to identify RNAs and proteins and signals that make axons grow as new treatment options in spinal cord injury. So again, I'd like to thank the Commonwealth of Massachusetts grant program and give my dedication to Travis Roy. Thank you very much.
The game was pretty much ordinary. It was 3rd and 1, and as I think back now, 3rd and 1 for a football player is a pretty important down. It's a game-changing situation. I found myself sprinting towards the corner. With everything I had, I dove, trying to stop him. And then I didn't feel a thing. I felt my body drop like a ton of bricks. And before I hit the ground, I knew I was paralyzed.
Mark Buonicani is president of the Miami Project to Cure Paralysis and stands as a beacon of hope for the millions of people around the world who suffer from spinal cord injuries.
You know, when I walked on that football field, I knew it was an important play. I knew it was a game-changing play. I didn't know it was going to be a life-changing play. We all recognized the need, and we used my injury as a reason to fight the fight. In a way, it makes this whole injury worthwhile to provide so much hope for people in wheelchairs, scientifically with our breakthroughs and now in clinical trials, and the people of the world with paralysis look to us. And we take that very seriously. It's a burden that we carry very, very strongly, but one that we will definitely deliver on.
Good afternoon. My name is Dr. Andrew Reisner, and I'm here to tell you about our project, pilot testing of a system for tight blood pressure management after acute spinal cord injury. By way of background, blood pressure can be very low and dangerously low after acute spinal cord injury, along with the damage to nerves that control movement in the extremities or sensation to the body. There can also be injury to the nerves that control blood vessels. Those blood vessels can end up paralyzed and essentially very loose. Blood can pool, blood pressure can drop. And the reason that's important is that leads to poor blood flow. And blood flow is really what is essential to allow for healing of damaged spinal cord. So therefore, it's very important clinically to maintain blood pressure, especially in the days immediately after injury. And there's studies, a whole set of studies that show that patients who have better blood pressure management regain statistically more function. This is done with medications, and the fact is, though, you have to give just the right amount. Too little is not good, but too much can actually be dangerous. So what's the problem? The problem is that ultimately clinicians don't do a very good job of maintaining blood pressure, and it's because it's not easy. Blood pressure is a moving target. It goes up and down on its own. And so imagine a little like trying to steer a boat on a day where there's lots of wind and currents and just trying to get the steering just right to keep yourself on track. It's that same issue, and that's been shown to be a problem, again, in a whole set of different studies that show that blood pressure is just not properly maintained. Our solution to this problem is an artificial intelligence-based software guidance system. This uses principles that, again, are very familiar, where we know about how statistics and models are used in weather forecasting, where the weather from a day ago and today is used to predict the weather tomorrow and the day after. And exactly in an analogous fashion, we do the same forecasting on blood pressure trends. And we look at the patterns and say, here's where it's going. And the value here is a principled reason to say, hey, it's time that I need to give a medication or let up on a medication. Now, in addition to the predictive model, we also have other functionality that makes this really appropriate for a medical grade device that can be used truly for patient care. And that includes detecting errors if the data are not being transmitted properly, making sure that there's controls for clinicians that make sense, that are intuitive, that are not prone to be misused. It requires developing training for the users, cybersecurity, et cetera. The sort of capstone of our research award through the Massachusetts Department of Public Health and the Spinal Cord Injury Program of the state is a phase 1 clinical trial. A phase 1 trial validates the technical performance of a medical device, and it has to be done under the FDA. And we're very appreciative for this support, because this is a very resource intensive project. There's extensive preclinical testing, which makes sense. You need to make sure that your system is completely safe for use in patients. And there's also a lot of resources necessary in running the study to make sure that you get the very best data for analysis, and that you could really rely on the data for making determination. We are very pleased that our results have been excellent. They have met or exceeded what we thought would happen before the trial. We have tested this now in 15 actual patients in the ICU of the Massachusetts General Hospital, and the prediction accuracy has been very favorable. We've also have a separate data set of 17 patients with acute spinal cord injury. These are archived data, and we feed this to the machine to simulate real-time use. And in this data set as well, the performance is just as good. In summary, we feel that things are going very well. There's still at least one big trial between now and being able to offer this as a routine therapeutic tool, but we are on track to have our capability, this tool available in the next 2 to 4 years for routine clinical use. And we are incredibly appreciative of the support of all of our sponsors, of Becca Thomas at the Department of Public Health of Massachusetts, of Dr. Eric Ruby, and of the state for sponsoring the acute spinal cord injury program. So with great appreciation, thank you to all, and we will keep up our work and stay on track. Thanks.
Hi, my name is Wise Young. I am the director of the W.M. Keck Center for Collaborative Neuroscience at Rutgers University. For the last 25 years, we've been working on treatments for chronic spinal cord injury, particularly to regenerate the spinal cord and also to treat neuropathic pain in people with spinal cord injury. We have done clinical trials in China. We're currently starting a clinical trial in the United States to see if we can get approval of the umbilical cord blood mononuclear cells and possibly lithium as well. We are very proud of Massachusetts WALKS. We have been a supporter for many years, and we believe that the effort in Massachusetts is very important for the work that is being done in the United States for spinal cord injury. I believe that we are very close to getting therapies into clinical trials and also approved for use to restore functions such as walking, bowel, and bladder function. We are very excited about the progress that is being made in many laboratories around the world, and I urge you to support this effort in Massachusetts. Thank you very much.
Neural reconstruction here means utilizing
surgical procedures to reroute a healthy peripheral nerve to connect it with a paralyzed peripheral nerve distal end to reanimate motor sensory function. Previously, my lab has published this paper in which we tested feasibility of borrowing a healthy nerve. Here is thoracic 12 nerve that is above a thoracolumbar ipsilateral hemisection injury at T13L1 spinal cord. To reroute it with the paralyzed lumbar 3 nerve. When we did this 1 week after spinal cord injury, as showing in this locomotion score evaluation for these animals, we found that the green bar, which are the animals received such a procedure within a week to 9 days after spinal cord injury, they all showed very robust functional recovery in locomotion for the affected hind limb. Here is a piece of video that you could appreciate that how this ipsilateral injury could completely paralyze the affected sides, resulting in permanent functional loss. With this procedure, we were able to recover that function. But if we look at the dark bars, those are the animals received this procedure 1 month after spinal cord injury. They did not show any recovery, imposing a challenge to applying this strategy for a chronic stage of spinal cord injury. And in those groups, we also found that if we put a nerve growth factor called FGF2 into the paralyzed muscle, the target muscle, that the rebuild reconstructs the nerve root are going to reinnervate, we found it can further enhance such functional recovery, suggesting that this reinnervation process is important, is very important, but also perhaps there are other neuroplastic events occurring within the spinal cord to reanimate the local motor generator circuits. Now we have focused our efforts on testing the same strategy after contusion injury. The contusion again took place in thoracolumbar segment, which is the second most frequent places injured in humans. When we done such a nerve rerouting, again, within the first 9 days, we again see a sustainable, this red line, functional recovery, this time from both legs, because this is a symmetric contusion injury. But if we wait for 8 weeks, the blue line, despite the nerve reroute surgery, the animals did not recover. We further explored a possibility of using stem cells to rejuvenate the late phase spinal cord after trauma. We injected these cells 1 week before such a nerve transfer procedure. And in the following week, at week 8 after injury, we did nerve transfer. And once again, the green line showed you the combined treatment can induce functional recovery. This is very exciting because we think we might figure out a pragmatic way to apply nerve transfer, which has known efficacy to chronically injured spinal cord. We're now concentrating on analyzing the key mechanisms that support such a reactivation of the lumbar locomotor generator circuits involving the neuromuscular junction repair, the outflow of this borrowed motor neuron control to the paralyzed muscles, and more importantly, as these other arrows showed, what are being sent back through sensory nerve to the lesion spinal cord. They can work in consortium to reactivate pattern generation, to reanimate both hind limbs.
On April 27th, I was riding my motorcycle. I was coming down a country road, and me and a woman were coming at each other, and she decided to make a U-turn directly in front of me. I ended up breaking my back at T3, T4. I had broke all my ribs, severed my aorta, lost my spleen, and ruptured part of my bowels. Prior to injury, I was a petty officer second class in the Coast Guard, where I was a maintainer on the C-130s. The Coast Guard let me go wherever I wanted to. We decided to come to Boston for Spaulding because of the reputation it has. The Spaulding people know how to talk to you and know how to answer your questions and know how to keep you going and keep you strong. I learned about the rewalk while inpatient, while I was still doing wheelchair exercises and basic stuff down in the gym. As soon as I was strong enough, they were able to get me a grant to be in the rewalk for several sessions. It's weird to be at eye level again with people, but it's really a great feeling. It's nice not to be looking up at everybody all the time. Because of my strength and everything, and I have the right people on my side, it's possible that I may become the first 100% disabled member of the Coast Guard. I'm looking to teach aircraft maintenance in the Coast Guard for 4 years, and then my final 4 years as a recruiter, and then maybe as an old man, teach American history. The biggest thing I would say to somebody going through an injury like mine would be to keep your head up, stay strong. Life isn't over, it's just different.
My name is Arthur Page, and it is my honor to speak on behalf of the Travis Roy Foundation. On behalf of the trustees, the staff, and the friends of Travis Foundation, we want to express our gratitude to Dr. Ruby and Senator Pacheco and everyone who has made the Massachusetts Spinal Cord Injury Trust possible and effective. We very much hope that it can be strengthened and continue to evolve as a national model. Trav always said that as a kid growing up in a small town in Maine, how good could he be as a hockey player? Could he actually play for BU? Could he make the Olympic team? Could he star in the NHL? I think in 2020 hindsight, the answer is clearly yes, he could. But his dreams were shattered in 11 seconds. And after those dreams were shattered, he took the same determination that he had as a hockey player and devoted it to helping others with spinal cord injuries. His father has said that Travis accomplished more in his wheelchair than he ever would as a hockey player. The foundation has raised over $20 million in its existence. Of the $20 million raised, a little under $10 million has gone for adaptive equipment, shower chairs, lifts, computers, van conversions for people to move forward with their lives. Over 2,100 individuals have been helped by the Quality of Life program. It is the largest program of its kind in the country. It is a drop in the bucket of what's needed for people.
This is Jason. A 2019 rock climbing accident left Jason, ironically at the time a neuroscience and biology double major, paralyzed below the waist. Travis visited Jason at Spaulding and encouraged him to apply for a ramp so he could return home and get back to doing research one day. The Travis Roy Foundation is so proud that these days, Jason is a research assistant in Dr. Hez's lab. Here are some words Jason has to share.
A while back, Travis gave a presentation in my high school called Just Wiggle Your Toes. It was a really amazing talk, but I never could have imagined that 5 years later, I would have also suffered a severe spinal cord injury, and now I can't wiggle my toes anymore. Since my injury, Travis and his foundation have been an amazing resource to me, and I can't wait to continue to honor his legacy by doing new spinal cord injury research.
While Trav was always a terrier, He made grants and taught courses at Harvard and did general rounds at Spaulding, as well as sponsored research and discoveries at Children's Hospital. At Spaulding, Trav would greet and meet and counsel other victims of spinal cord injuries. Not only that, but he also talked to the doctors and the researchers as to what their thoughts were and their avenues towards research and how they would affect someone like himself who was in a chair. Trav thought that for a quadriplegic, the most important thing to do was to get arm and hand coordination back. If he could move around his kitchen and make a meal for himself, he would have more independence and self-sufficiency. He hated the fact that he was in a chair and others were in chairs, and that they were dependent upon others for daily needs. Research often looks at getting people to walk, but for a quadriplegic, in order to instill independence and self-sufficiency, you need your arms and hands. And so he moved the focus of the research in that direction. Travis loved getting people together, and people loved getting together with Travis. He would invite young researchers and doctors over to the headquarters of the Travis Roy Foundation and have them share their stories and share their experiments with each other and with him. It was networking, and that networking, Travis always believed, would pay off in the long run. The research is moving forward. We have the resources here in terms of people. We have the resources here in terms of physical attributes. We have the network. What we need is funding and the determination to make it happen. Hopefully we can solve the mystery of spinal cord injuries through that combination. Everybody in this room deserves an enormous thank you from everybody from the Travis Roy Foundation. They've opened our eyes to new discoveries and new possibilities, and we urge them all to go back to their labs and redouble their efforts. They are the super people. They are the ones who are going to find the answers.
For me, the research we fund, it's all about hope. It's knowing that there will be a better day, not only for those of us that are in the wheelchair, but for our loved ones, our family, our friends. As you can imagine, spinal cord injuries, it is a devastating, catastrophic, life-changing challenge that affects everyone. And I am glad and I'm hopeful and I'm excited about the role the Travis Roy Foundation plays, and we will get there someday. But we're not there yet, and we can still use your help.
Thank you all for your participations and infomercials. I also want to recognize, as part of our network, Encompass of Braintree and Woburn Rehabilitation Hospitals, the Christopher and Dana Reeve Foundation, the North American SCI Consortium, the New England Paralyzed Veterans Association, Project Walk of New Hampshire, and the Boston VA. Spinal Cord Injury Awareness Day is about networking, partnership, and collaboration. The traits in common for our grant recipients and the paralyzed community are creativity, innovation, persistence, passion, purpose, and courage. Hope is an attitude. Research is our strategy. Funding makes it happen. In our quest for a cure, we have gone from impossible to improbable to inevitable. If we can put a man on the moon, we should be able to cure spinal cord injury paralysis. Now for the Q&A with as much time as we have left. Thank you.
The first question that came to me actually came on my phone even before noontime, and it was about how Senator Pacheco might be helpful in adapting homes for um, better energy consumption. So we could fight global warming and actually start with the disabled community. I will talk to Senator Pacheco directly and perhaps connect them with the person who asked me that question. The other questions were about actual numbers, and I will connect whoever asked me those questions with Becca from Department of Public Health. The next question actually came from Jeff Macklis, who wanted to discuss something with Chris Gable. And being that Jeff is one of the panelists here, perhaps he can ask that question directly.
Sure. Thanks. I don't want to take time away from all of the rest of the participants, but Chris, I probably missed it in your first slide. What kinds of neurons are you looking at this single cell level? I saw the image of the fluorescently labeled cell, but what system is that?
Yeah, so it's actually in C. elegans. So these are in intact C. elegans, which is a small nematode and a very powerful model organism for genetic studies. And so we can go in and cut individual axons. Is it that one we were looking at was it's a sensory neuron. They don't have a peripheral versus a central nervous.
Yes, right. And my follow-up, which should only take a second or two, is that a laser lesion that you're then doing? I was assuming this was once. Okay, great. Thank you.
Yep, great.
Okay, other questions were about networking and information. And my feeling is that the Greater Boston chapter of United Spinal Association puts on programs that are absolutely remarkable. And I won't go with names particularly, but anybody who wants information about connection. Ryan, is there a particular website that they should go to, or an email for asking those specific questions? Because we're talking about both rehabilitation and research. And your researchers are now on the panel. So if you have particular questions for a researcher, please state them or write them down here so I can see them. And it's in the chat. I can't find the Q&A anymore, Ryan.
Okay.
That disappeared.
So Eric, I can try to help you out, but Ryan can probably try to help you find it. But there is one question. I'm looking at 3 questions that maybe the 3 or 4 of us could try to answer quickly. And Ryan, I don't know if you want to organize or if we should just go through in order. There's a questions from Vandana Vyas, from Ryan Solinsky, and from Abby Swain for all of us to discuss.
Yes, if you can see them, you're more than welcome to answer them yourselves. But I can't see them, Dr. Ruby. If you'd like me to help with that, that's fine with me.
I can only see chat right now.
Okay.
And they're not in chat. They must be in Q&A, but I can't find Q&A.
Sure.
Okay, so Eric, Vandana Vyas at 103 asked, I would like to know if stem cell treatment is effective after 18 months of injury. And Zhigang, I don't know if you want to try handling that, or I could, and you could weigh in, whichever you want to do. And Christopher, I'm only passing because I'm thinking you may not want to tackle that. So I'll take Zhigang. Do you want to? So I would say, Vandana, that's a longer conversation. There's been a lot written on that topic, but most, not all, most work that claim to use stem cell treatments, and there are literally hundreds of kinds of stem cells, have not either a thoughtful basis of use or have not been shown to be useful. There are a couple of exceptions, one including the use of certain kinds of stem cells to try to rewrap, remyelinate the neurons that Professor He and I were talking about coming from the cerebral cortex down to the spinal cord or from the periphery up to the brain to rewrap them if they've been banged and injured, but not actually crushed or severed. And those so-called oligodendrocytes have been one somewhat promising approach. There are some other approaches trying to rewire circuitry, but I think those are still at experimental levels, work by Mark Tazinski and others in San Diego and other groups, but those are not yet ready for prime time for humans. Even though there are some groups around the world that for a lot of money will sell you such treatments, I think there's very little or no evidence that they actually help. But Zhigang, I don't know if you want to weigh in with something different than that. You're muted, Zhigang.
Oh, yep, you are muted. Actually, all the presenters, if you'd like to unmute yourselves, that would be fine.
Yeah, no, I totally agree with Jeff. I don't have anything else to add.
So then another question from Ryan Solinsky is for Dr. Reisner. And Dr. Reisner, I know, wrote on the chat that he would be happy to join, but he hasn't been invited yet. I don't know if he's still there.
I thought I did, but I may have not hit the right button. I'm sorry about that, Dr. Reisner.
So maybe we'll leave his question. Or are you going to be able to get him, or should I go on
to right now? Yeah.
So we'll go on to Abby Swain's question. Abby writes, "Forgive me for this question, but is any researcher game to try to sum up whether and how the various threads of nerve-focused research we heard about today complement one another rather than pursue disparate competing paths?" And I think Abby asks a critically important question in this whole field of how do we put together information that comes, for example, from Dr. Gabel's work in C. elegans worms that gets at very basic questions of how does a nerve cell control its energetics and its metabolism to grow, to the kind of work that Dr. Morgan talked about in very evolutionarily ancient lampreys that don't have a brain as we know it, but have a spinal cord. So there was a lot learned about certain elements over the years to then work perhaps that Zhigang might want to weigh in on, or I would weigh in on, that try to take some of those basic elements that have been learned over the years and bring them into the mammals' cerebral cortex and spinal cord, mostly using mice because they share brain structures and genes and systems with humans. So I think the field tries to integrate these things, but you're absolutely right that each of these experimental systems gets at different elements that contribute in spinal cord injury. So that would be my brief answer. Chris, Zhigang, I don't know if you want to add in.
No, I guess that, yeah, I would agree wholeheartedly. I think if you look at all the basic research talks, we're all looking at some level at the genetic level and trying to understand what genes are involved in different parts of the process of nerve damage and recovery. And then when you start looking at those pathways that we discover, they end up overlapping and lead to a central biology. But it really it boils down to the genetics, trying to understand which genetically what needs to go on in a neuron to get it to regrow. I think that's sort of the overall theme that a lot of the basic research is at.
Yeah, no, I agree. I think everybody working on our own favorite model system, but with strength and weakness, none of this model is 100% equal to human patient. I think we have at least for people in this panel, we have extensive collaboration. Jeff, we have ongoing collaboration. Chris, Actually, we have a few papers together in the past. So I think we have been, even though our presentation has been only focused on whatever we are the project supported by this project, but we have a lot of extensive collaboration trying to learn from each other.
And if I could add just, and then we can maybe get to Dr. Reisner's, the question for Dr. Reisner, just to follow up, I think Zhigang's absolutely right. And to put a sharper point on that, a PhD student in Professor He's lab was a student in my lab for a time earlier, and we're doing a direct collaboration between our labs, and I'm an advisor for her career progression. So we're trying not to just have these be, as you pointed out, disparate competing paths, but rather paths that try to take lessons from one and build in another. So yeah. So maybe Eric, if you're still not seeing it, maybe I can read the question from Ryan Solinsky.
Yes, thank you.
Dr. Reisner, your study uses AI to predict mean arterial pressure changes. With new research coming out on potential superiority of optimizing spinal cord perfusion pressure over MAP, how adaptable is this platform for future advances in endpoints?
That is a fantastic question. So whoever asked the question is very, very deeply knowledgeable. We are working with Brian Kwan from University of British Columbia, and he has actually provided us with, and this is also a additional aim actually of our state-funded program, and he has provided us with measurements of intraspinal pressure from his patients in Vancouver. And the answer is that on a broad level, it's very applicable, although you still have to do a whole new trial. So the platform is completely applicable. We are looking actually at his data set, and although it seems that intraspinal pressure is better correlated with outcome, it also, when we've done some simulation studies for how often would you have actually managed the patient differently if you're just looking at arterial pressure versus the spinal perfusion pressure, which is the difference of blood arterial pressure and the intraspinal pressure. It's only a few different changes. Now that might be very important for those few folks where there is a difference, but the long story short is applicable. It would be a next step, and we are, that is within our sights as well. So thank you for a very thoughtful question.
Jeff, are there any others there?
Yes, I'm happy to keep on going. I just didn't want to usurp your
I am
chair's
delighted.
position. Okay.
This is questions for researchers. I'm not a researcher, I'm a coordinator. So thank you.
So I'm going to be a coordinator of researchers.
Okay,
Jason Biundo asks, is there a list of SCI conferences available somewhere? I don't know if somebody knows this offhand. I think Google is such a good search. There are meetings around, but Zhigang, I don't know if you know of a centralized list.
I know Jason actually is right now is in my lab. Jason, please find me. I will tell you some meetings to attend.
Okay, you have a direct advisor, Jason. So Jason also asks, do you anticipate different challenges for treating SCI at immediate post-injury versus chronic SCI, greater than 2 years post-injury? So Zhigang, do you want to tackle that since you're going to start giving an answer to Jason anyway?
Maybe you can go ahead. I can talk more with Jason afterwards.
So because there's some other questions, I'll answer very quickly. I think at a very first level, there are clear differences because early after an injury, there are challenges of the local damage and potential bleeding, inflammation of the tissue, reducing additional injury, reducing things like we call ischemia, or lowering of blood pressure in the local area. So there are many challenges then. And then even in the ensuing days and weeks and months, there are somewhat different challenges because the nervous system has been injured, but it hasn't yet scarred itself or responded to injury and close things down. And then I think many of us in the SCI research community do distinguish between enabling growth more acutely after an injury. For example, if one is using mice or rats or something in the weeks or month or two, and that can be a much different situation than dealing with an animal or a human where it's been a year later and the nervous system has totally adapted to the injury and has changed connections and things like that. So Zhigang, I don't know if you want to add on to that.
Yeah, no, Jeff, I think you give a very nice explanation already. I guess, it's still a little bit too early. I think because of the major challenge, most of people have been pretty much focused on acute spinal cord injury. Overall idea is that once we find something useful for the acute condition, then we can test in the more chronic condition. There are some good examples already. For example, the P10 deletion promote axon regeneration acute injury. There are some report over there. If you delete a P10 in cortical neuron from chronically injured mice, it still can promote regeneration, but that will take much longer time.
So 20 years ago, when my son was first injured, we were told the faster he gets back anything, the better it is, because if he doesn't get it back, it's still going to be a problem. Initially, methylprednisone was in vogue. Most recently, it was hypothermia. Travis actually had told me that with intense physical therapy, he was actually getting back something in his hands. I think that Patricia Morton from the Keck Center had stated in the chat about Wise Young's clinical trials that were successful in China with umbilical cord blood. So things are happening. And I also would like to say that the disparate needs to come together, but going in a lot of different directions is appropriate because thinking outside the box has to be important, but also doing a step-by-step in a scientific fashion, as Jeff has done. I think that there will be many modalities that may be helpful because spinal cord injury is quite complicated and the etiology is not always the same. The pathophysiology doesn't always seem to be the same. But Jeff, I know you'll have something to say about what I just said.
Yeah, and I'm willing to take some heat, and I was going to go to Patricia Morton's response, presumably to the comments that I made and that Zhigang agreed with. Zhigang, I'm pulling you into this. And Patricia Morton, who I've met once or twice, who I can't remember your title, but Dr. Morton is director or executive director of the Keck Center with Dr. Weiss-Young. And wrote, Dr. Weiss-Young's clinical trial using stem cells was approved by the FDA. Now, I'll go into what that means. It was halted by COVID, but a new application has been submitted. This trial uses umbilical cord blood mononuclear stem cells. So a trial being approved by the FDA doesn't mean that the therapeutic is approved. It means that the trial, and that's typically to look just at safety, meaning if by doing this, are we going to hurt somebody? has been approved, and there needs to be some rationale from so-called preclinical trials, typically in rodents. And there have been some rationales put forward that umbilical cord blood in multiple systems can modify the immune response and regulation during an injury. I don't know if these were the preclinical trials that were put forward in support of getting approval to try this trial, but I just double checked on the FDA website, and as recently as June 3rd, 2021, they might have something newer. They have, and everybody interested, and Vandana Vyas asks the next question, so I'm going to refer you also to this. There is an FDA alert, which is important patient and consumer information about regenerative medicine therapies. And they point out that the FDA regulates these, and there has been broad marketing of unapproved and unproven products around the world. And these need to be, before approval, these products require oversight in a clinical trial. And these can be recovered from your own body. They list umbilical cord blood, etc. But they point out that none of these have shown efficacy to date. Efficacy means usefulness. So if you are being offered any of these products outside of a clinical trial, and there I'm going to applaud the Keck Center and Drs. Young and Morton, doing clinical trials where they will get data about folks who have or don't have, and what goes right and what goes wrong. And if one wants to enroll in that clinical trial, then I urge you to contact Drs. Morton and Weiss. But otherwise, to Vandana Vyas, who wrote a nice comment to me. This is Vandana, thank you for your answer. I'm thinking to go to India for autologous stem cell for an L10 injury and paraplegic. My view is I can either be nice and polite when I go around the world, or I can be honest and try to help people. There are lots of what many people, and I'm saying that so I'm not the one calling them that, any lawyers in the crowd, many people, including an entire group of the Howard Hughes Medical Institute and an entire group of the Society for Neuroscience, have called such efforts charlatans, because they often charge $10,000 or $15,000 or sometimes $35,000 for injections with entirely unproven efficacy and frequently downsides. And there are many case reports starting in 2004. Gareth Cook, I think, who won a Pulitzer Prize for the Boston Globe. There was a big 60 Minutes expose, and there have been many others of these fee-for-service clinics who charge considerable amounts of money, and people end up with tumors up and down their spinal cords or elsewhere. So be very, very careful. This is not the United States withholding treatments from you. It is the FDA of the United States protecting you from folks who are going to inject you with unknown products that are typically just a tube of blood that theoretically holds a few stem cells. So now I've probably made some enemies, but I think I've protected some people. So Zhigang or Chris or Andrew, I don't know if you guys want to weigh in.
You know, I think we're in a good way. There's the gap between our patients, the public, and what's out there is just a Google search away. And I think it's generally good that people are knowledgeable. But I 100% agree with you that you know, the one thing I think as clinicians and researchers is we have some perspective, and there's even a lot of therapies that go through early trials, and they do have evidence, and then they, with more experience, they don't always pan out. So I just wanted to support what you said, that it's not a matter of withholding, and this goes for spinal cord injury or other things that we read about in the media. It's that once you've been around the block a few times, you know that you need to get good data and how to do science. And, you know, we're really leading the country in best practices to figure out how to innovate safely. And so I just wanted to say, I thought you were very articulate. And as hard as that is, I just wanted to say you have my support in how you explain that for all the folks out there weighing their different options.
Great. Now, before Zhigang or Chris, I'm just going to give Dr. Patricia Morton a time to comment herself, because she wrote back, presumably in response to my comments. Dr. Young's trials are for people with chronic injuries. So that's, again, the difference between acute and chronic. And she says, thank you, Jeff, for the warning. There is a lot of, quote, snake oil, end quote, out there. So one needs to distinguish between well-done clinical trials that look at even surgical placebo effects, which have been proven in the field to exist and be very substantial. And Dr. Morton is reminding us to be careful about clinical trials done well and fee-for-service, not clinical trials. But Zhigang, Chris, I don't know if you want to weigh in.
I think I agree with you. And not also, even what we are doing is only in animal. I think it's still too far away from the clinical side as well. It's not like we have something better than those things. I think just very rigorous science still required for all kind of research before getting to clinical side.
So I thank everybody. It is now after 1:30, and Chris and Ryan and I talked about limiting this. If there are more questions, we'll try to answer at another time. But I do want to say that the people in chairs, there's an entire spectrum, certainly from paraplegia to quadriplegia. And one of the comments was that I am paralyzed, but I have a normal life. And I didn't want to downplay anybody and their quest for a quality of life and activities of daily living. That's what it's all about. There is certainly hope within the practical aspect, and there are a number of agencies that people can contact to get help with their wheelchairs, with their cars, and now also with home health aid. On the other side of that, we are still doing the research, and I think the research, there's a reason that they're phase 1, phase 2, and phase 3, safety, efficacy, and then 6 months of seeing what really happens. So I do believe that people want a cure. I think throwing caution to the wind is not a good idea. And if it sounds too good to be true, it probably is too good to be true. We need to have the basic research. That is why my grant proposals have always gone to basic research. We opened it up to some clinical trials this time, but now we have a sufficient amount of funding that we will be able to create a broader spectrum towards basic research and clinical research. So unless there are other comments, I want to thank Jeff Macklis right off the bat. He has been quite a supporter for everything that I've been doing. And if I ever have a question, he's the one I ask. So, but thank you all, Chris and Zhigang, Andrew, I'm sorry Ted is not on, but Ryan, thank you so much. I hope we will do this in person next year, and it's not a slight to Ryan, but if we do this by Zoom next year, please make sure I get to see the Q&A. So
we will work on that. We will certainly work on that. Thank you very much, Jeff, for helping with that too.
Thank you.
Okay, and thank you all, and see you next year. And certainly we can communicate at any time during the year.
Great, thank you. And thank you for everybody for coming.
Yes.
Thank you so much.
Thank you,
We
everyone.
did have 94 participants at one point. So that was good. Okay,
Thank you,
bye-bye.
everyone.